In this video, we're going to talk about linear applications. We're going to focus on what is needed for linear applications, and then in class, you'll talk about how to solve certain applications. Let's consider this. If a larger integer is 2 more than 4 times another integer, and their difference is 32, can we find the integers? We have a lot of information here. Now we can take this sentence and translate it into mathematics. We already talked about that in a previous class, in previous video. But now we're going one step farther. We are going to be creating the equation, and then we'll be solving that equation to actually find the answers or solutions to the equation. So we need to know how to translate the sentence into a mathematical statement and then solve. Now we've already practiced translations and we practiced solving equations, so now we're going to put it together. But before we get into that, let's talk about problem solving in general. When we're problem solving, regardless of whether it's a linear application, quadratic application, or any type of application, there are a few things that we want to consider. There's about 4 or 5 steps depending on how detailed you want to be per step. In the college algebra textbook, it does give you a how-to on how to solve linear applications. This is my version of solving problem-solving applications. The first thing you want to do is read the problem at least twice. Read the problem once to get an overall picture of what's actually being talked about or what's presented, and then you read it a second time. The second time, identifying the key words, phrases, and organizing given information. You want to identify the variables by assigning a letter or expression to those unknown quantities. So in step 1, we identify what we know. We also are looking at what we don't know. And then we're going to let these unknown quantities give a letter. When you are identifying the variables, you want to give the unknown quantity a letter or variable, and you want to state what that variable is representing. A letter or variable without its meaning has no meaning. So if we're looking for example, if we're looking for the amount of corn, then X would have to equal amount of corn. I just can't have X be X by itself. It has no meaning. Applications have meaning and context, and so should the variables associated with those. The step 3 is to translate or set up an algebraic equation that models the problem. You want to be able to write an equation that talks about the relationship between what you know and what you don't know. What you know and what you don't know. So for example, if I know that I have a sum, but I don't know what I'm adding together, I can at least write x plus y equals whatever the total sum is. Then I would have to figure out what I can write y or x in terms of the other, and then replace that. Remember that for these problems, we're only going to be having one variable in our equation. Even if there's 2 unknowns, we can write one of the unknowns in terms of the other variable. Once you have your equation, you're going to solve that equation. And then you'll find a value to one of your answers, or both answers. And then you want to check your answer just to make sure it makes sense. If you're looking for a positive integer and you come up with a negative answer, something went wrong. If you're looking for a integer and you get a fraction, something went wrong. So you always want to check your answer. You also want to make sure that your final answer is has a correct label. So if we're talking about a measurement in feet, then your answer should be written in terms of feet. If your final answer is about time, like minutes or seconds, make sure that label is there for your final answer. Remember, applications have context, and therefore their numbers have meaning other than simple 2 is 2. This section, we're only using one variable. So we're always going to be able to rewrite one variable in terms of another if there are 2 variables. Later in the semester, we will talk about how to solve equations if there are 2 variables present instead of just one. So now let's solve. Using our model. Okay. If a larger integer is 2 more than 4 times another integer, and their difference is 32, find the integers. We have some key words here. We have more than, times, difference. We know we're going to have addition, multiplication, and subtraction. The question is, what is the overall arching connection? I also know that I need to know I have a larger integer and another integer. So I have two integers that I do not know the values of. So I'm going to go ahead and define those variables. I'm going to let x equal the larger integer. And I'm going to let y equal another integer. I have identified and labeled my variables. Notice I picked a letter and I stated what that letter represents. It's not just a letter, it's a letter with meaning. The variable has meaning in this problem. Now, I know that I'm going to be adding 2 and multiplying something by 4. I also know I'm doing a difference. Let's look at the difference part. What are we subtracting? We are subtracting the 2 integers. Now, which one goes first? X or y? So if we look at their difference, let's highlight that. Blue. Ooh, nice. Their difference is 32. What are we subtracting? We're subtracting the variables x and y. So x minus y equals 32. Now, I don't know how to solve an equation where there's only one variable. So I need to rewrite one variable in terms of the other variable. Now we need to use this first part. The larger integer is 2 more than 4 times another integer. Well, I know my other integer is y, and I know my larger integer is x. So what I have is x equals 2 plus 4 times the other integer, which is y. So really, I can rewrite this as 4y plus 2. So if x is the same thing as 4y plus 2, I can now take this expression and replace it for x. So my new equation becomes 4y plus 2 minus y must be 32. Now I have one variable with an unknown. So I have done the first step, which is read the problem, and then I read it again, picking out the prominent information. I actually have two equations here. I have the difference equation, and then I also have the 2 more than 4 times the other one. I combine those two equations together using substitution. Remember from evaluation where we had to replace values for variables? Well, that's what we did here. It just so happens that instead of it being a number replacement, we're putting in an expression. Now I can solve this equation to find the value of y. 3y plus 2 must be 32. 3y then must be 30, and therefore y equals 10. If y is 10, then we can replace here, this 10, can go back into here so we can find out what y is, or find out what x is. If x equals 4y plus 2, then x must be the same thing as 4 times 10 plus 2, which means x is equal to 42. The last question we have to ask ourselves is, does these answers make sense? Well, if x is 42, that is clearly larger than 10. so x is the larger number. Is 42 2 more than 4 times 10? Well, 10 times 4 is 40 plus 2 is 42. So that relationship holds. And if I were to subtract the numbers, 42 minus 10, do we have a difference of 32? And the answer is yes. So then we would finally say that the integers are 10 and 42. And here we've done our final step. We've labeled our answers. Since all these are our integers, we simply just we stated that these were integers. And that's it. This is what we call a direct translation problem because the equations come from a direct translation. However, a lot of applications require prior knowledge to come up with a relationship equation. Some of the prior knowledge that you might have to use for linear applications are as follows. You might have to remember the geometric formulas from our previous unit. How do you find perimeter? How do you find area, volume, surface area, even angle formulas, and the triangle sum theorem? There are also some basic algebraic formulas, such as the amount equals base times rate. If we think about tax rates or interest rates, this is where this will come into play. You'll also need to know some definitions. What does it mean to be consecutive? What does it mean to be an integer? What does it mean to be positive? And what does it mean to be negative? This is not an extensive list. There are many different things that you might need to know for prior knowledge in order to solve these applications. What we're going to do is we're going to look at a few problems and determine what prior knowledge we need to help us solve the application. And in class, we'll go over how to solve them specifically. So what prior knowledge is needed? The sum of 3 consecutive integers is 99. What are the integers? In order to help us come up with the equation, we need to know what sum is. We need to know what consecutive means. We need to know what it means to be an integer. These are the 3 key words we need to know. Once we have that, we can come up with the equation for this problem and then solve. The perimeter of a rectangle is 52 inches. The length is 2 less than 3 times the width. Find the dimensions of the rectangle. Here we need to know what the perimeter of a rectangle is. Perimeter of a rectangle. In other words, we need to know that formula for perimeter. We need to know what it means to be less than and times. We also need to know what they mean by dimensions. Without knowing these keywords, it would be really difficult to come up with the equation to solve the problem. So again, we need to know, let's highlight. We know what the perimeter of a rectangle is. We need to know what less than is, what times is, and what dimensions are. Now let's look at the second one, or the next one, number 3. Kelly has invested her total savings into $750 into 2 accounts. One fund earns 4% interest and the other earns 9% interest. After 1 year, Kelly earned $40 in interest. How much was invested in each account? There's a lot of information here, but we really only need one piece of prior knowledge to help us with this. And this is that formula of the amount, in this case the interest, earned is equal to the interest rate times amount invested. Now this is your basic A equals R times B, where A stands for amount, R stands for rate, and B stands for base. In this case, A is your interest earned. Your R is the interest rate. And B, ooh, terrible purple, is the amount invested. Now there's multiple different, we have two different accounts with two different interest rates and two different amount invested, but that's okay. Since it doesn't overlap, we can come up with the equation here. So again, we needed to know this prior knowledge for this equation alone. Two planes leave the airport at the same time traveling in opposite directions. The average speeds for which the two planes are 450 miles per hour and 395 miles per hour. How long will it take the planes to be 1,478.75 miles apart? Here there's a lot of information, but there really isn't a clear idea of how these are connected. Here's your prior knowledge. You should know from prior knowledge that distance equals rate times time. Now don't be fooled. This is the same relationship as A equals R times B, where the amount is equal to the rate times the base. In this case, the amount is the distance, the rate is your speed, and base is your time. With this information, we can come up with an equation to figure out this equation. But this is only the prior knowledge that you need. Without knowing this formula, distance equals rate times time, or distance equals speed times time, you would not be able to come up with the equation for this one. Shorthand, D equals R times T, which notice the parallels between this and this. The relationship is the same, but we specifically put different variables here to represent distance. But again, if distance was amount, and our speed was our rate, and our base was our time, we would have the same relationship. In the last problem, in a triangle, the measure of the angles are given by 4x plus 3, 8x minus 10, and 3x. Find the measure of the angles. What do we need to know about this prior knowledge? Here, we know that we're given a triangle. And we're given three measurements. 1, 2, and 3. Since we're given a triangle and angle measurements, the triangle and angle measurements suggest or point to the triangle sum theorem. Which means we have to use the triangle sum theorem in order to figure out the equation. It's all about what you know. And if you have more prior knowledge, the easier these problems will become. You'll see that a lot of these will have similarities, especially the ones that use the amount equals rate times base. A lot of problems in it with linear applications uses this at some value.